All right, so cooling the machine and restarting it got it to work. And so here's what you get when you run auto runs. Here you can see the log of what it did, connected to the machine, installing the product, downloading some stuff. And the answer is 1,346 rows of stuff. So a lot of things are automatically launching. Now the results are here. Here's a list of 1,300 things. You could look through it in this GUI, but that's for the birds. What's better is to download it. That's JSON, and this is CSV. So the easiest thing is download it as a CSV and then open it in a spreadsheet. And I've got a Mac here, so the Mac has a spreadsheet client on it by default. I thought I would see it here. Yeah, there it is. That's the one that just came down. Okay. So if I open that thing, double-clicking it should open it in the default spreadsheet application, which is, yeah, here we are, Mac's imitation of Excel. All right. And so now you can view a big list of things like this, and you can sort it, which is what we're going to do, of course, because 1,300 items is too many. And let me zoom in. There's my zoom. Good. All right. So here you have time. This is the location of the registry key that makes it launch. Here's the name of the product, enabled category description. So all that is not too important to us right now. What's important to us is company. The company is the company that signed this software. And therefore, if I find something that does not have a company on it, that is suspicious. So what I want to do is sort this. And I think I'll just try selecting all, Control A, okay. And then find a data sort, which is format, table, arrange. There is some way to sort in this thing. Well, there's sort options. There we are. Show sort options. Okay, sort entire table, and I want to sort by that column called company name, which is column H. There we go. Company. All right, good. That should do it. Company ascending, that would be fine. Sort now. Sort now does nothing. Oh, yes, it did. Okay, it's alphabetic now. Okay, good. So let's get rid of that. That was organized. So here I have companies like Advanced Micro Devices and Cisco and stuff like that, and that's fine. But what I want to do is find the ones that are unsigned. And by the way, I'm not entirely sure this is a signature. Maybe it's just the name in the properties sheet. But anyway, something that's not got any company name associated with it is more likely to be suspicious. And so here we are. All right. So here's the ones that are unsigned from here on down, 1,272. And you see one of them is Velociraptor itself, which I know is all right. And if I go back here, I can see the names of these things. And one of them should be PUP. What I was hoping to find. But I'm not having much luck finding it. All right, I had some way of tracking it down, but let's just see if I can. Let me see if I can find the word PUP in here with Alt F. PUP. There it is. Yeah, that's what I was looking for. There's something called PUP4. All right. And I think that's the only occurrence in the run key. So there is an automatic launching process named PUP4 and with no identifying information. And here's another one, PUP4 message. and that is the name of the running process, PUP4 message. Again, that's the same thing. PUP4 is the name of the key in the registry that launches it, and PUP4 message is the thing it runs. So I now have a suspicious looking process with no company name and a suspicious looking name here, so I have a hypothesis that that program is responsible for that pop-up message, but I haven't proven that yet. So that's the next thing. That's the CSV. Now, then I want to get the MD5 of that exe. This is something I might want to do. Then I can see if it's known to be malware. So we can do that with PS list. Let's get rid of this spreadsheet. And I don't need to save it. All right, so let's get a PS list, a list of running processes. Now I know it automatically launches. And of course, I knew that it had to be running because that box has popped up. So let's go to PS list, and if I go to parameters and look here, I know there's going to be a lot of running processes, and now I know the one I'm interested in contains the word PUP. So instead of having a dot, which would give me everything, I'm just going to put PUP in here and only get the running processes with the name PUP. And now I'll launch that one, and I shouldn't be getting 1,200 answers anymore. If I go to my log, it's already done after 1/10 of a second. Here's my results. I've got one answer, and here it is. The PUP4 message process is running, and now I have the MD5 hash of the executable. And I could put this in VirusTotal, one of these hashes, and see if it's known to be malware, and it's not. At least I wasn't when I tried. I only wrote this a while ago. Somebody might have put it up there. Let's try it and see. I wonder if you can do an MD5 at VirusTotal. You might have to do one of the more modern hashes, but let's try it and see. VirusTotal. If I search by a hash, my goodness, 2 people have already declared this, 4 people already declared as malicious. That's exciting. They may have detected some of the techniques I use, or maybe somebody reported it. Let's see. There's details, there's relations, there's behavior. One match for PowerShell create scheduled task. Okay, that's good. They're detecting heuristically what I did. I used PowerShell to create a scheduled task, and they're detecting that that's suspicious. All right, anyway, so you get some information from VirusTotal about it. So now I have some indication that this thing might be the malicious process, but I haven't really proven that it's responsible for that thing that popped up. And to do that, I want to do the process memory. So I go here, and I run triage. And it's this Windows triage process memory. This will dump process memory and download it so I can examine it. So I configure parameters, and again I want to get the right process, so I think I can just use PUP. It's the only process with PUP in its name, and launch that. And here's the log. Okay, it started running. This is good. And it's got to download 12 megabytes of stuff, so it's done, and it has downloaded stuff. If I go to results, that's here, and if I go to uploaded files, here's the file containing the process memory, which is what, 30 megs or something like that. So I can click on that, and now I've got it on my machine here, which is a Mac. So I could view it in various ways. It's a raw hexadecimal, raw binary dump. So I'll open it in a hex editor. I've got one on my Mac that will do. All applications, hex fiend, that'll be fine. Okay, so here's the process memory from that running process, and remember it popped up a message saying you are pwned, so I could look for that string with I think it's up here. If I do find, just a moment, there it is, find. Okay, let's do text for pwned, and It is not found, but the reason it's not found is because it's in Microsoft Unicode, which means you have to put a null byte after each one. So I need to find the series of bytes. Those are the ASCII characters, and in between I need to add a null after each one. So null, there we go. There, that's the Microsoft encoding of that word. Let's see if we can find that. And there we have it. Your machine is pwned. The message that pops up is there. So now we've verified that that running process is in fact causing the pop-up. All right. Now, the next thing is to see what other files on that machine are involved in the attack. So now I have a indicator of compromise is that word pwned. I want to see if other files on the box contain that string. So I want to run Yara. Yara is the tool that searches through files for a text string. So I got Windows detection Yara NTFS, and this will let me do a Yara rule, and notice they'll make me have a shorthand Yara rule in the form of wide no case ASCII : string string. So if I know it's a wide string, so I can do wide : string as my Yara rule instead of writing a formal Yara rule which has a little bit more syntax. So configure the parameters here. Here's my path regex, and what I want to do is I want to look for all executables on the box. So I'm going to get rid of all the path here, and I'll just get rid of the .2 and just put exe. This is the simplest answer. This will just look for any path ending in exe, which will be all the executables and possibly a few other files, but that'll pretty much be executables on a Windows box. And I don't care about the date or anything. I just want to put a Yara rule here, and that rule is going to be wide : pwned. So now it'll look for Unicode pwned in every executable on the box. And this, by the way, is the one query that forces you to use the old version of Yara. The new version of Yara will not let you put in a simple regex like this, and I could not figure out how to get a regex that would do it. They've changed the regex processing, and it seems to me between the Linux interpretation and the Windows interpretation, something is lost, and I can't figure out how to scan every exe on the box. So I'm just using the old version, and there it goes, compiling the rule. Failed to open one file, I guess because it was open, but that's okay. I'm looking for error messages. When I ran the latest version, all I got was error messages that the syntax of my path was wrong. But this has not that kind of error message. It's moving. Now this will take a while. It's scanning every box. Yeah. I passed the PUP. Right, thank you. You saw the PUP 4. Anyway, so it's pretty surprising to me that it works this rapidly. It'll take, I think, maybe a couple of minutes, but it is scanning every file on the whole box. And I'll just show more rows. You can see it's going, and occasionally, and notice there it says it will use accessor. It's directly going through the direct access to the disk, not going through the Windows file system, which makes it faster, and it also means it can access certain files that are not accessible the other way. So it's pretty cool. And it is time limited. These things will only run for a certain number of minutes before they just give up, to avoid burdening your endpoint with some query that's taking too long and slowing it down. And you can adjust that time, although I've never done it. But it is designed to not mess up your machines, because the point is you're of course doing a live acquisition on live company machines that are probably in use. So you don't want to lock them up or crash them or anything. So here it is scanning files, and you see it's occasionally had trouble reaching, failed to open it, so it opened it another way, and so on. So it's, by the way, not able to open every single file, which is not too surprising, but it will eventually scan them. And like most, so it's got some results. It found a thing called CPUP4 message. That's the only thing it found. Now this is the same executable that was running. And if it's done, it's not done yet, then we will have some reasonable confidence that there are no other executables on the machine involved in this attack. although they could be there and not have that word pwned in them, because, nothing is perfect. There, it's done, and the only thing it found was PUP4 message. So there don't seem to be other files included in the attack. And I said there's a remediation. Let me show you that, although it didn't work. But in principle, you can open a shell on your box. So you go here, Home, and then Show All, and click the client ID in blue to get back where you start. And now there's a shell button. So in principle, I can now execute PowerShell commands on the machine. So, but what you'll find is they don't work. So for example, here's one of the things I tried to do. I tried to delete that file. That would seem like the thing to do, delete that PUP4 message. So I launched that, and I'm not sure what this does. I think it shows me the results, what this does. Yeah. Anyway, it doesn't work. That file is still going to be there. As far as I can tell, this shell is not really working very well. So anyway, all right. Anyway, that it does exist. So that's all I wanted to show you about that one. Let me stop this recording.